everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation from Cauchy's equation. We are going to solve a Cauchy's equation. Okay, we are going to reduce the given differential equation with variable coefficients to Cauchy's equation. So let's get going. Problem: x square into d square y by dx square plus 4x into dy by dx plus 2y equals to x square plus 1 by x square. Given differential equation, x square into d square y by dx square plus 4x into dy by dx plus 2y equals to x square plus 1 by x square. We know that d is a differential operator whose independent variable is x, right? Then d square will be d square by dx square. Now we can write the given equation as x square into d square y plus 4x dy plus 2y equals to x square plus 1 by x square. Now take y common from all the three terms of LHS. We'll get x square d square plus 4xd plus 2 into y equals to x square plus 1 by x square, which is a Cauchy's equation. Right? Now we'll reduce this equation to a higher order linear differential equation with constant coefficients. So we are having here variable coefficients, right? So it will change to, the total equation will change to linear equation with constant coefficients simply by making a substitution. X equals to e power z, then log x equals to z for x greater than 0, and let theta equals to d by dz. Here theta is a differential operator whose independent variable is z. Okay, and we'll replace x d by theta, x square d square by theta into theta minus 1. Right? Now this equation becomes, that means Cauchy's equation becomes, replace x square d square by theta into theta minus 1 plus 4 into replace xd by theta plus 2 into y equals to replace x by e power z, will get x e power z whole square plus 1 by, here also replace x by e power z, will get e power z whole square. Right? Then theta into theta, theta square minus theta into 1 theta plus 4 theta plus 2 into y equals to e power 2z plus 1 by e power 2z. Now this equation becomes theta square minus theta plus 4 theta is plus 3 theta plus 2 into y equals to e power 2z plus 1 by e power 2z can be written as e power minus 2z. So this is of f of theta into y equals to some function of z, right? That is, which is an operator form, we can say. Which is an operator form. Where f of theta equals to theta square plus 3 theta plus 2. Now we need to find the general solution to the given equation, which is given by y equals to yc plus yb. So now let's find yc and yp. We'll find yc using the auxiliary equation. The auxiliary equation is f of m equals to 0, where f of m equals to, we have f of theta, theta square plus theta plus 2, right? Let's replace theta by m, so that we'll get f of m equals to m square plus 3m plus 2. Now our auxiliary equation becomes m square plus 3m plus 2 equals to 0. Now split 3m as 2m plus m. Take m common from the first two terms, we'll get m times m plus 2, and the next two terms remains the same. We notice that m plus 2 exists in two terms, so let's take m plus 2 common. We'll get m plus 2 into m plus 1 equals to 0. Now we equate each factor to 0 to get roots. From m plus 2 equals to 0, we'll get m equals to minus 2. And from m plus 1 equals to 0, we'll get m equals to minus 1. So the roots are m equals to minus 2 and minus 1, which are real and distinct, or we can call them as real and different. Okay, roots of our auxiliary equation. Therefore, m equals to minus 2 minus 1 are the roots of f of m equals to 0, which are real and distinct. Now let's write our complementary function. We know that when two roots are real and distinct, say m1 and m2 are real and distinct, then yc will be c1 into e power 1 constant into independent variable z plus another constant into e power another root into z. Now our yc looks like 1 constant into 1 root into z plus another constant into e power another root into z. This becomes c1 e power minus 2z plus c2 e power minus z. Now let's write this in terms of x. Okay, so we are having in terms of z, right? We'll change it to x. Now to change it to x, let's write e power minus 2z as e power z power minus 2. Okay, plus c2 into write e power minus z as e power z whole power minus 1. Now it's easy to replace e power z by x. Okay, then yc becomes c1x power minus 2 plus c2x power minus 1. We can write x power minus 2 as x square, 1 by x square, right? To write more clearly, c1 into, right, x power minus 2 as 1 by x square, since x power minus n equals to 1 by x power n, plus c2 into 1 by x. So this equals to c1 by x square plus c2 by x. Therefore, y is equals to c1 by x square plus c2 by x. Let's now find yp. We'll find yp using 1 by f of theta into RHS part. That is e power 2z plus e power minus 2z. Okay, we have f of theta, theta square plus 3 theta plus 2 into e power 2z plus e power minus 2z is equals to 1 by theta square plus 3 theta plus 2 into e power 2z plus 1 by f of theta, theta square plus 3 theta plus 2 into e power minus 2z. So we can find each term separately. This is of 1 by f of theta into e power az form also. The second term is also of 1 by f of theta into e power az, right? So we'll go with this procedure now. Coming to the first term of yp, 1 by f of theta into e power 2z. So this is of 1 by f of theta into e power az, as I said you earlier. Now, compare e power 2z with e power az. Then for a equals to 2, we have f of theta equals to theta square plus 3 theta plus 2, right? Let's find f of a. For a equals to 2, we'll find f of 2. Simply replace theta by 2. Then we'll get 2 square plus 3 into 2 plus 2, which is equals to 4 plus 3 2s are 6 plus 2, which is 10, right? Non-zero. Since f of 2 is non-zero, so we can replace theta by 2. Then we'll get 2 square plus 3 into 2 plus 2 into e power 2z, which is equals to 1 by 4 plus 3 2s are 6 plus 2 into e power 2z, which is equals to 1 by 12 into e power 2z, or we can write it as e power 2z by 12. Okay. What happens if this is equals to 0? If f of 2 equals to 0, we cannot replace theta by 2, because if we replace theta by 2 in the denominator, we'll get 1 by 0 into e power 2z, right? Since 1 by 0 is undefined, so total term becomes undefined. Okay. Then we'll find f dash of theta. Okay. Just we'll use the known method. So we got the value for the first one, that is e power 2z by 12. Now let's go for the second one. One by f of theta into e power minus 2z. Right? Now for a equals to a equals to minus 2, we'll find f of a. F of a equals to f of minus 2 equals to minus 2 whole square plus 3 into minus 2 plus 2, which is equals to minus 2 square is 4 plus into minus 3 2s are 6 plus 2, 4 plus 2 6 minus 6 equals to 0. We got f of minus 2 equals to 0. So what we'll do is we'll write one independent variable into 1 by. Now see, in the denominator of previous step, we are having f of theta, right? Now we need to write f dash of theta. We'll get f dash of theta equals to 2 theta plus 3. So write f dash of theta in the denominator, 2 theta plus 3 into e power minus 2z. Now find f dash of minus 2. We'll get 2 into minus 2 plus 3 equals to minus 4 plus 3, which is equals to minus 1, non-zero. Since f dash of minus 2 is non-zero, so we can dare to replace theta by minus 2. Then we'll get z into 1 by 2 into minus 2 plus 3 into e power minus 2z, which is equals to z into 1 by 2 into minus 2 is minus 4 plus 3 into e power minus 2z, which is equals to z into 1 by minus 4 plus 3 is minus 1 into e power minus 2z. We can write 1 by minus 1 as minus 1, right? Which is equals to minus z e power minus 2z. So the result obtained from the second term is minus z e power minus 2z, right? Now coming to yp. Then yp becomes, result obtained from the first term is e power 2z by 12 plus result obtained from the second term is minus z e power minus 2z. Now we need to replace, now we need to write yp in terms of x. Okay. For that purpose, we'll write e power 2z as e power z whole square by 12 minus z into, write e power minus 2z as e power z power minus 2. Okay, now replace e power z by x and z by log x. Then yp becomes x square by 12 minus, replace z by log x, will get log x into x power minus 2. Since we know that x power minus n equals to 1 by x power n, so we can write x power minus 2 as 1 by x square, right? Then this becomes x square by 12 minus log x by x square, which is our required yp. So we got yp and yc. Let's write the general solution. The general solution is given by y equals to yc plus yp. Then y equals to yc, we have c1 by x square and plus c2 by x, and yp is x square by 12 minus log x by x square. This completes the problem. Here you can write log x as log x to the base e. So we have seen a problem from Cauchy's equation in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.